Welcome student to Praveen Patil College of Diploma Engineering and Technology. Now today's lecture obviously depend on the chapter number 2 derivative. In today's lecture we have to discuss about logarithmic differentiation. Take the natural logarithm of both sides of the equation and use the properties of logarithm to write as a sum of simpler terms. Differentiate both sides of the equation with respect to x. Solve the resulting equation for dy by dx. Let us check the example based on this. Differentiate the function in log x raised to cos x. Y is equal to log x raised to cos x. Taking log of both sides, we have log y is equal to log x raised to cos x. So cos x, we know that log a raised to b is equal to b log of a. So that's why cos x is there, log of x. Log y remain as the same. Differentiate both sides with respect to x. Derivative of log y, derivative of cos x into log x dx. So we know that the derivative here is possible. So dy by dx, we have to take the derivative of y is dy by dx. Now product rule is applied for this derivative. Cos x is different function, log x is different function. So that's why using product rule in the cos x log in bracket log x. We know that derivative of u into v is u derivative of v plus v derivative of u dash, or reverse way we have to take. Now 1 upon y dy by dx, I take the derivative of cos x first into log x remain as the same plus derivative of log in bracket log x dx and cos x. We know that derivative of log y is 1 upon y dy by dx. That's why derivative of cos x is minus sin x, log in bracket log x remain as the same. 1 upon log x, how it is possible? Yes, we know that log in bracket f of x is 1 upon f of x into derivative of f of x. So 1 upon log x into derivative of f of x, that is the derivative of cos x we have to establish. Yes, derivative of log x is possible and cos x is remain as the same. Now minus sin x is remain as there, log in bracket log x plus 1 upon log x into 1 upon x, where it is possible? Yes, log x derivative is 1 upon x, cos x remain as the same. 1 upon y dy by dx is equal to minus sin x, log in bracket log x plus cos x remain as the same, x log x. Now we have to shift 1 upon y to this side. We derive dy by dx is equal to y in bracket minus sin x into log in bracket log x plus cos x upon x log x. Now in this way, find the dy by dx if y is equal to x raised to x plus x raised to root x. We have to consider u is equal to x raised to x and v is equal to x root x. These both functions are in a logarithmic form. Which form? The x is the function and x is also function. Function raised to function, we have to use logarithmic differentiation. Now u is equal to x raised to x. Taking log of both sides, log u is equal to log x raised to x log x remain as the same, because we know that log m raised to n is n log of m. 1 upon u, log u is equal to 1 upon u du upon dx. X, derivative of log x is 1 upon x plus log x remain as the same, x derivative is 1. Now equating part is start, x log x get cancelled, plus log x remain as the same. So 1 plus log x is there. Now du upon dx and u goes this side. So du upon dx is equal to u 1 plus log x. U is the x raised to x, 1 plus log x. Now v is equal to x raised to root x. Taking log of both sides, log v is equal to log x raised to root x. We know that log m raised to n is n log of m. That's why root x is in multiplication, log x remain as the same. Log v derivative 1 upon v dv upon dx, root x remain as the same. What is the derivative of log x? 1 upon x. Plus log x remain as the same. What is the derivative of root x? 1 upon 2 root x. So 1 upon root x, how it is possible? Yes, we know that root x whole bracket square is x. So 1 root get cancelled. In a denominator we retain 1 upon root x plus log x upon 2 root x. Now we have to shift the v this side. dv upon dx is equal to v in bracket 1 upon root x plus log x upon 2 root x. We have to substitute the value of v is what? X root x. Now dv y is equal to u plus v, that is dy by dx is du upon dx plus dv upon dx. That's why we have to put the du upon dx is what? X raised to x 1 plus log x, and dv upon dx is what? X raised to root x upon 1 upon root x plus log x upon 2 root x. So we derive the final answer of y is equal to x raised to x plus x root x derivative is x raised to x 1 plus log x plus x raised to root x up bracket 1 upon root x plus log x upon 2 root x. Now derivative of the parametric function we have to discuss. How it is possible? So here be confirmed, let a differentiable parametric curve be defined x is equal to f of t and y is equal to g of t. Consider g dash of t is equal to dy by dt. So dy by dx is into dx upon dt. So dy by dt dx is equal to f dash of t. So dy by dx f dash of t g dash of t, or dy by dx is equal to g dash of t upon f dash of t. In simpler way we have to find this as a simple pattern. Find dy by dx when x is equal to t square, y is equal to 2t. X is t square and y is equal to 2t. We have to take the derivative with respect to t. So we know that x square derivative is 2x. That's why the derivative of t square is 2t. We know that t derivative is 1. Why? Because x derivative is 1. That's why 2 into 1 is 2. So we have know that dy by dx is dy by dt upon dt upon dx. That's why dy by dt into dt upon dx means what? We have to multiply. So 2 into 1 upon 2t. So 2 get cancelled. Final answer is dy by dx is equal to 1 upon t. Or you can write dy by dt upon dx upon dt. We derive the same answer in the parametric function t. Now given that x is equal to t square, y is equal to 4t. What is the derivative of t square? Yes, 2t. What is the derivative of t? 1. 1 into 4, 4. X dash represent dy by dx upon dt. Y dash represent dy by dt. So we have to put in formula dy by dx is equal to y dash of t upon x dash of t is equal to 4 upon 2t. So 2 2's are 4. So 2 upon t is the final answer. Suppose we have to find dy by dx when x is equal to t cube minus t and y is equal to 4 minus t square. X is equal to t cube minus t, y is equal to 4 minus t square. We have to find derivative with respect to t, dx upon dt. What is the derivative of x cube? Yes, 3x square. That's why the derivative of t cube is 3t square. What is the derivative of x? 1. That's why derivative of t is 1. Y is equal to 4 minus t square. Derivative of 4, 0. Derivative of t square minus 2t. Therefore, from chain rule, dy by dx is dy by dt upon dx upon dt. So, minus 2t upon 3t square minus 1 is the final answer. If x is equal to 3 sin theta, means sin trigonometry function is there, y is equal to 4 cos theta. In previous example, t is parameter, here theta is parameter. That's why we have to take the dy by dt, no. We have to take dy by d theta is equal to minus 4 sin theta, dx upon d theta 3 cos theta. dy by dx is equal to minus 4 sin theta upon 3 cos theta is equal to minus 4 sin upon cos is tan 3. So that means gradient of theta is equal to pi by 4. So we have to put the theta is equal to pi by 4. That's why dy by dx is equal to minus 4 tan pi by 4 is 1. Final answer is minus 4 upon 3. We have to find d square y dx square as a function if t x is equal to 1 minus t square upon t minus t cube. First we have to find dy by dx. dy by dx is equal to dy by dt upon dx upon dt. What is the derivative of t? Yes, 1. What is the derivative of t square? 2t. So we have to write 1 minus 2t here. What is the derivative of t? 1. What is the derivative of t cube? Yes, it is 3t square. Now we have to must revise. Derivative of a raised to b constant is 0. Derivative of f of x raised to b is b f of x raised to b minus 1 into f dash of x. Derivative of a raised to g of x is a raised to g of x log a into derivative of g of x. Derivative of f of x raised to g of x is f of raised to g of x f dash of x upon f of x log f of x into g dash of x. These formula are important to solve the example of parametric function, logarithmic function, exponential function. Now we have to using logarithmic differentiation to find this derivative. Y is equal to 2x raised plus 1 raised to tan x. First step, take the natural logarithm of both sides. We have to take ln y is equal to ln 2x raised to 4 plus 1 raised to tan x. Expanding using properties of logarithm. We know that what log m raised to n is n log of m. So tan x log 2x raised to 4 plus 1. Ln remain as the same. Differentiate with respect to x both sides. Ln of y 1 upon y dy by dx. We have to take u into v rule. That's why differentiate both sides, use the product rule. What is the derivative of tan x sec square x? Ln 2x raised to 4 plus 1 remain as the same. What is the derivative of 2x ln 2x raised to 4 plus 1? Yes, it is 1 upon 2x raised to 4 plus 1 into derivative of 2x raised to 4 plus 1. What is the derivative of 2x raised to 4? Yes, 4 2s are 8, x raised to 3. That's why final answer is 8x cube upon 2x raised to 4 plus 1. What is the derivative? That is tan x remain here same. Be considerable. Here we have to take tan x derivative. Ln 2x raised to 4 plus 1 remain as the same. Here we have to take ln 2x raised to 4 plus 1 derivative, that is 1 upon 2x raised to 4 plus 1. Derivative of 2x raised to 4, that is the 4 into 2 8, x raised to 3, and derivative of 1 0, and tan x remain as the same. Equating part, y shifting this side, dy by dx is equal to y in bracket sec square x ln 2x raised to 4 plus 1 plus 8x cube 2x raised to 4 plus 1 into tan x. We have to substitute y is equal to 2x raised to 4 plus 1 raised to tan x in bracket sec square x ln 2x raised to 4 plus 1 plus 8x raised to 3 upon 2x raised to 4 plus 1 into tan x. So we have to substitute this way. These are steps we have to write in the right hand side of the PPT. So we have to follow and use. What? Taking natural logarithm, expanding using properties of logarithm, differentiate both sides using the product rule, multiply y both sides and substitute y is the f of x is given. Example of logarithmic differentiation. Find dy by dx. For y is equal to x raised to cos x. Take log of both sides. Ln of y is equal to ln x raised to cos x. We know that log m raised to n is n log of m. That's why cos x here, ln x is here, ln y remain as the same. Differentiate with respect to x to both sides. Therefore, derivative of x in bracket ln of y is equal to derivative with respect to x cos x into ln x. Cos x, derivative of cos x is minus sin x, derivative of ln x remain as the same, plus cos x, derivative of cos x ln x is 1 upon x. Now we have to apply dy by dx is equal to y shift this side minus sin x into ln x plus cos x upon x. We have to resubstitute the value of y is equal to x raised to cos x in bracket minus sin x ln x plus cos x upon x, substituting the values of y. Now here the most important thing is there. Derivative of ln x be considerable 1 upon x. Derivative of ln of f of x is 1 upon f of x into f dash of x. Derivative of log x to the base a is equal to 1 upon x ln a. Derivative of log f of x to the base a is 1 upon f of x into ln a into f dash of x. This rule to reference for the example. In this example, we have the 1 minus y x 2 plus x bracket square 3 minus x bracket cube upon 4 plus x raised to 4. We have to take the log of both sides. We have to take the ln of y. So log, we know that log means it is multiplication. There is a plus 1 upon 1 plus minus cos x, 2 upon 1 plus